So you should all have a review sheet in front of you. So the study guide that has been provided by the district, because that's who makes our tests, is closely aligned to your final exam. So really use that as your study guide. If you have questions on anything, please ask. I will save like the last 20 to 25 minutes of today and tomorrow, and probably all of Monday, to answer any of your questions as a class. Because I know even though I tell you, you know, asking you when you have questions, there are still kids that will for some reason not ever ask me a question. All right, so maybe those kids can benefit from watching other people ask me questions and going over those problems. All right, but I really went through the test and wrote down your success criteria, which is literally everything that's going to be asked on the test. So like you need to be able to identify coefficients as the number in front of a variable, to identify exponential growth and decay and interpret them and all this other stuff. So it's limited to just semester 2 stuff on the final, so that's nice. And that study guide again is your guide for the test. It's actually 2 pages worth. You'll get the second page tomorrow, and we'll go from there. You may not have enough room to do all the work on that paper, so feel free to use an extra sheet of paper if you need to. And I've kind of decided to be nice, and I think I'm going to let you use your review sheet on your final exam. So, you know, that gives you more incentive to do it. And I am recording myself for those people that maybe they want to see other problems worked out and linking it into Schoology. So yeah, the final exam is split into 2 parts. Part 1 you will take on Tuesday, and everyone will take part 1 on Tuesday. And then I will not see you guys on Wednesday. I'll see you guys Thursday, and you'll take your part 2 on that day. So both parts are 20 questions each, all from semester 2, and it's worth 10% of your grade. Now let's be honest. The final, more often than not, at least in math, brings down students' grade more than it brings them up. All right, so just kind of prepare yourself. Look at your grade now. Everyone that normally tests with me, your grade is 100% up to date. Anyone that normally tests with Ms. Turan, your topic test is up to date, the retake that you took yesterday. But I still need to adjust your quiz scores. So that's going to take me a little longer because I'll wait till all the absent people get theirs done and I'll just do it all at the same time. But basically your grade, aside from the final exam, like your semester grade, that 90% chunk won't get any lower as of right now. So some of you are on that borderline, and by borderline, I mean anywhere from like, let's say 86 to 89% or whatever it is. Some of you are on that borderline to getting a higher grade, and some of you are on that borderline to dropping a grade because of your final exam. So just kind of prepare yourself. One thing that I've been showing everyone today that you guys could do is look up a final exam calculator. Literally just type it into Google. There's tons out there. I could also show you how to calculate it by hand, but let's be honest. It's a lot easier just to do the final exam calculator. So there's tons out there. Just click on maybe like the first one. That one seems pretty good. And let's say your current grade is, let's go with 86%. And you want to have at least a 90% in the class. So you're shooting for an A. Well, the final exam is worth 10% of your grade. So then you need to score at least 126% on your final. Is that possible? No. So if I were that person and I was really shooting for an A, then I would be doing more than just studying for the final. Because one, it's already hard enough to get 100% on the final, but there's no way you can get 126%, right? So today and tomorrow could also be spent doing test corrections. So you can ask me and I will say yes, except for the topic 9 test until everyone's taken that one. And then you can work to improve your grade that way. at least as like a last ditch effort. Now, say you are a person who's maybe like at a 50% and you want to get just a passing grade in the class. Again, you need to be doing more than just studying for the final. All right. Say that person passes the final. You can make a good case for yourself that, you know, because I passed the final, I should pass the class. You can make a good case for yourself. I'm not going to say like, if that happens, I will absolutely bump your grade, but I'm going to look at a lot of things. I'm going to look at, did you work hard these 2 to 3 days that we are working on the study guided class? Did you do your missing work? Did you turn in your binders? Like things like that. Did you sleep during my retakes? I look at things like that. So I was pretty peeved at one of my classes today because even after telling them all this, they just wanted to spend their time playing games on the computer or sitting on their phone, basically not doing everything but the final exam study guide. So I know like when those kids come up to me later on and say, what can I do to bump up? I'm so close to the next grade. I'm going to say nothing. Could have done stuff back then, like right now, you all, but you wasted that opportunity. That's how it is. I've kind of been on the fence about maybe being nice and still having tutoring tomorrow after school. But the way that I see it, we have like 2 hours, like today and tomorrow, to do things like test corrections and other things to get your grade up. So depending on like how hard people work and if they do need that extra tutoring time, then I'll have it. But I'm not going to if it's just a bunch of like sleeping and playing games and all that stuff. All right, questions about that? Yes, Brayden? Yes. All right, any other questions? All right, so the key is on the back wall for your review sheet. There's no work shown, so if you have questions, do ask. And yeah, we'll go over them. We'll go over some questions in like the last 20 or 25 minutes. So we'll start here at number 13. I was saving the last 20, 25 minutes anyway to answer questions as a class, but I feel like multiple of you would have a question on this. And it's on number 13. So it says the first 5 terms of the sequence are 8, 11, 14, 17, and 20. Write the explicit and recursive formulas for both. Luckily, on your test, it will be multiple choice, so you'll just have to recognize which one's the explicit and recursive for a problem like this. But I don't really expect you to have memorized the formulas for explicit and recursive, so write them down. Explicit is A sub n equals A sub 1 plus D, and then in parentheses, n minus 1. All right, so this formula can help you find any term in the sequence. That's whatever term you're looking for. Say you're looking for like the 100th term, would replace n. So n stands for n, whatever term you want to find. So when we're making the rule, the A sub n will just stay A sub n, unless they tell me to look for a specific term. A sub 1 stands for what? Your first term, which makes sense. If A sub 100 would be the 100th term in the sequence, then A sub 1 is my first term. What's my first term in the sequence? 11. Actually 8, so there's an 8 up here. It's not on the same line. So that's why I moved it down here. But 8 is the first term, so that's why I wrote it over here. Plus the common difference, which what is my common difference? 3. And yes, it's plus 3 because we're adding 3 each time. If we were subtracting 3, then we would put minus 3. All right, and then the n minus 1 stays n minus 1 unless they give you a number to plug in for n. All right, but that's an example of how the rule would look. And this is just for arithmetic. I know somewhere else on the test it asks for geometric, which is different when you multiply stuff each time. This is for arithmetic sequences when you're adding or subtracting each time. Good so far? All right, it also asks for the recursive rule, which is down here in black. So that one, well, here it is written. It's a sub n equals a sub n minus 1 plus b. And then usually they still put it somewhere in the rule that a sub 1 is the first term. It's not part of the formula, but it's like added onto it. And all that this recursive rule is saying is that if you take a term, like the previous term, and add the common difference to it, you get the next term. So like if it wanted the term after 20, well then I would just take 20, add 3, then that's my next term. Make sense? So that's all it's saying. But then to plug it in to the rule, the ends will stay ends unless they tell you to find a specific term, plus the common difference, which we said was 3, so that's why right here it says plus 3. And then usually they still identify the a sub 1 as part of the rule. So a sub 1 is the same. Questions on 13? All right, which others do you have questions on? Number 7. All right. So find the zeros by factoring. By the way, don't get confused by the word zeros. What's another word for zeros? X intercepts. What else? Anything else? There's solutions. There's quadratic roots. So all of those vocab words are interchangeable. Make sure that you can still identify it when they're talking about finding zeros. We're basically just asking what values of x is across the x-axis. So what's my values of x? This one tells you solve by factoring. So anytime that you're factoring, what do you always look for first? Yeah. The GCF. So always check for GCF first. There will not always be one. Is there one in this one? No. So then you move on to step 2, which is to count how many terms you have. How many terms? 3. And when I have 3 terms, there's actually 2 ways of factoring. One is when a is 1, and the other is when a is not 1. So what method do I use when a is 1? The diamond method. So diamond method is a times c on top, b on the bottom. So negative 21 and then negative 4. Fill that in. Miss Medina. Yes. I'll ask her, and then if not, then I'll send her. Okay. All right, fine. All right. So what 2 numbers multiply to negative 21 but add to negative 4? There's not really many numbers that multiply to 21. So here's your option. Which ones can we finesse a little bit to multiply to negative 21 but add to negative 4? Good. So the negative has to go on the 7 if we're going to add to a negative. Everyone good so far? And when a is 1, it's pretty easy. You can just kind of remember this, but it's only when a is 1. Your answers will be basically the opposite of what's in your diamond, but only when a is 1. So x will be 7 and negative 3. And the way that that works, just in case you're curious, and maybe it'll help you remember, is because when we get this from our diamond, we set it up like that as factors, and then we set each factor equal to 0 and solve for x. So what's opposite of subtracting 7? Good, so that's why we get one of our x's as a positive 7. What's opposite of adding 3? Subtracting 3. So then that's how we get the other x as negative 3. So questions on 7? All right, which other ones from the review sheet? Yes, number 9. All right, so minimum, maximum is referring to parabolas, by the way. And if you look at this equation, it is a parabola. It's just in the vertex form. All right, so first you need to know that minimum or maximum is talking about your vertex. And when it's in vertex form, like this equation is, so actually, let me write it off to the side. When it's in vertex form, you can actually easily see what the vertex is without doing like the axis of symmetry formula. So vertex form looks something like this: y equals a parentheses x minus h squared plus k. And the vertex, anyone remember what it is when it's in vertex form? Which of these letters tell me what my vertex is going to be? HK, good. So when it's in vertex form, your vertex is HK. Now keep in mind, the normal equation looks like this, where it's minus h and plus k. So that means that whatever sign is on the h in your equation here is actually going to be opposite for when you put it in as a vertex. So my h is actually, and I'll write it in vertex form. My h is actually -2, so opposite of how it looks in your equation. My k matches the equation always. So if it's -5 in the equation, it'll be -5 as your vertex. So that's the answer for number 9. For B, with the h, like I just always think of it as, what do I have to plug in here for it to become a +2? And if I plug in a -2, well, what happens to that double negative? It becomes a positive. So that's why it looks positive here, even though it's actually a -2 that you plugged in. But the k is normal, treat k normally. Questions on number 9? All right, I know it's getting kind of messy. Which other ones would you like to see? Number 10? Okay. So then let me put this on a different page so that it's less messy. All right. So literally the test, your final exam looks just like your review. So you will have a problem just like this. So this problem, you have 2 polynomial expressions being added together. Don't forget what is always outside a set of parentheses, even though it's not written. A 1. And yeah, when you multiply stuff by a +1, it doesn't make a difference. Like what's 1 times 7p cubed? Good. But that's like how you get rid of the parentheses, is by distributing that 1 that is out there. And sometimes, like it's not in this problem, and I didn't see it like that on your test. But sometimes there's a -1 out here, which would change things. All right, but since it's a +1, you know, this is what we get after distributing. On the first step so far? All right, so then let me just make sure I didn't copy something wrong. All right, then from there, after distributing, you combine like terms. So like terms have the same exact variable to the same exact exponents. So do I have a matching like term with the p cubed? Yes, I have a 7p cubed and a negative p cubed. Remember, when you combine like terms, you just add the coefficients. So what's 7 plus negative 1? 6. And then you leave the variable the same. Don't change the variable when you're just adding or subtracting. It's p cubed. This is a p cubed, that's a p cubed. Right? Well, we have another like term. So is there a like term that goes with this p squared? What is it? So then add the coefficients with 6 plus 7. Good, so plus 13p squared. And then lastly, do we have a like term that goes with the negative 5p to the fourth? Good, so then add the coefficients. What's negative 5 plus negative 6? Negative 11p to the fourth. And I don't know if it says to write it in standard form, so your answer might look like this, or how would it look like in standard form? Good. So if it makes you write it in standard form, remember standard form is ABC order with the higher value exponent first. So p to the fourth, p cubed, p squared, just reordering them, keep the signs with the term. Questions on this one? All right, which other ones? Number 12. So 12 is not as hard as you think. It says graph below shows the equations of this and that. Find the values of x that are solutions when we put them equal to each other. So that's what we're doing. We're putting a parabola equal to a straight line. And that's what you see on your graph too. Solutions are always going to be, at least when you put stuff equal to each other, of lines, is going to be where they intersect each other. Because they're set equal to each other right now. So wherever they intersect each other will be a solution. So like I have a solution here. Anywhere else? Do you have another solution? Do these two lines intersect each other at any other parts? Where? Like right here, right? And luckily it'll be multiple choice. So even though that one we kind of have to estimate a little more, you should be able to see where they intersect as a solution. So like the coordinates of each of these, like this one is all right, this one is -2, -3. This one is, we have to estimate it a little bit more, but it looks like about 3.5 and maybe a little bit more than 5. All right, and then because it says find the values of x that are solutions, then my solutions are just talking about the x of each of those coordinates. So the -2 and the 3.5. If it said find the values of y that are solutions to this, which I've never seen it do that, but if it did, it would be the ones. Questions on this one? All right, any other ones? You're all going to see these problems again on your final, so. All right, going once, going twice. All right, so then continue working. Some of you left, so you didn't